Hi everyone, my name is Amit. I'm a senior scientist at Amazon where I build and deploy optimization models and now AI agents for worldwide operations, supply chain operations, I should say. And today I'm here to present my work on this summarization framework for generating insightful narratives. So I'll start with the problem statement, why it's important. The framework that I proposed in the paper along with the experimental results. And we'll conclude with some key takeaways and opportunities for future work. So what's the problem that I'm trying to solve? Essentially, back when I started my career, I was an analyst. I would essentially work with C-suite executives. They would ask for some insights, usually in PowerPoints or Word documents going in the form of narratives. And my workflow would essentially start with collecting data, building dashboards, gathering insights, looking at charts, tables, and then feeding into narratives. And now you would wonder with generative AI and LLMs, you could just feed the entire problem into an out-of-the-box LLM model and then expect some, if not all of the problems be automated. And you could see where the challenges lie. One, LLMs can hallucinate. So they can misquote numbers or they can miss out numbers that are actually should be quoted in the narratives. And they don't pay attention to especially the hierarchical structure of the data. So if let's say your data is like at country, state, city, and zip code level, LLMs essentially are not able to understand that data hierarchy and then extract the insights for the leadership narratives. So with these challenges, I looked at what has been done in the literature, and I found I would say two themes of work. One is this table to text generation, where you have a table and then you want to generate a text out of it. So this becomes like a large language models are like really good at generating text or even generating code. So this works, but without getting any insights from the table itself. And the other approach is kind of using RAG or this text to SQL approach on doing Q&A on the underlying tables. So you feed the table through a RAG framework, which is retrieval augmented generation, or use some text to SQL frameworks and then ask questions in like single turn, and you would get responses without any insights being essentially generated and shared as a result. So with those in mind, what I propose is this multi-agent / tool summarizer framework where we break the problem down into simpler components where based on the narrative and based on the insight that we want to generate, we would actually first filter the data or slice the data for the respective, let's say, time periods or dimensions. And then you would do this contribution / variance calculation, where based on the filtering that you did in step 1, you would essentially calculate at certain level of hierarchy what is the contribution for, let's say, for a given month across different levels of hierarchy. And then the third component is context agent, which is if there is an external event that has happened in specific time period, and then you want that to be included in the narrative. So that essentially is kind of like an optional component. And then finally, then all of this gets sent to the LLM to then summarize and then generate the insight with the prompt that the user has defined. So deep diving into some of these components. So as I said, slice agent essentially will filter the dataset into subtables based on the hierarchy that insight essentially is being generated on and for specific time periods. So for example, if you want to see the impact of one specific business metric from Q4 2024 over, let's say, Q1 2025, so it will create those two different tables for those two time periods with the same granularity. And then variance agent will essentially compute the delta contribution at that level of hierarchy, see if there is any context that is important for either of those time periods, whether it's Q4, considering it's a holiday season, and then prompt the LLM to generate the narrative using all of the output generated by the agents before. So the implementation is actually done using LangGraph. So LangGraph is an agentic framework from LangChain, where all of these tools / agents are actually nodes. They are defined as nodes. And then in this case, actually on the previous slide, you would see that they are actually in series and they are executed in sequence. But this is modular. So you can actually pick and choose and figure out, and also have a reasoning model on top to decide which agent needs to be called in what sequence, and then finally to generate the executive summary. So for results, obviously getting the data for any of these experiments, especially with LLM, is really hard. So I looked at a Kaggle dataset with around 100,000 samples, and then I established these two baselines. One being if the entire table along with the prompt is sent to the LLM and then asked to generate an executive summary with insights. And the second where the narrative itself is kind of predefined with the X and Y, and then LLM is then asked to fill in those X and Y. For evaluation, I primarily focused on faithfulness and coverage. So faithfulness means what is the proportion of facts that are actually captured in the source table, and coverage means once the insight is generated, what percentage of delta or contribution were actually highlighted in the narrative. So with these three metrics, I found that the modular agentic framework and approach actually works well when it actually comes to coverage, because if you modularize and break the problem down into slicing the data and then computing these measures like with brute force and then passing all of that information to LLM, actually makes it more reliable and more insightful as compared to just throwing everything at LLM and assuming LLM will do its job with its reasoning and then will also quantify all the right metrics that you want to see in the narrative. Then I conducted few ablation studies to see what is the contribution of each of these components, and I saw if you remove the variance agent, the coverage drops dramatically, because in that case, though you are able to quantify the metrics across two different timestamps, across two different time periods at different level of granularity, but you are not able to quantify why something has changed, and it's almost going down to like identifying the root causes. If let's say revenue changes, then it is because the units went down or the average selling price essentially went up. So of course, this study has limitations. One, there is high reliance on the prompt itself that user has to generate for creating the narrative. And there is also a generation risk for the LLM as these LLMs essentially become more and more, or at least once they improve their reasoning capabilities, some of these tasks can actually be outsourced to the LLM. For example, filtering the data. So in future, maybe LLMs can actually filter the data on its own, and then also the variance calculation or the contribution calculation can also be done with the reasoning models. Another limitation is it is limited to structured data only, so it does not take into account any, let's say, information from external sources, news articles, and then kind of feed into this agentic framework. So to conclude, I would say LLMs out of the box do not work really well for generating insightful summaries, and the way to sort of generate this summary is to break it down into simpler components of what are the different tasks that are needed to generate the summaries, which is get the data, slice the data, calculate the contributions at different levels of hierarchy, add in the context, and then feed it to the LLM to just finally create the narrative, which they are really good at currently. And then ablation studies showed that variance calculation or contribution calculation is really important, and it kind of improves the relevance of the narrative that's generated. So next steps on this work, obviously this is work in progress, so I would love any feedback, any critique, questions that anybody has. But I want to benchmark this with text to SQL and kind of like extension or combination with reasoning models, because now as the models are becoming larger and larger, their reasoning capabilities are increasing. So the data slicing part can actually be done by text to SQL, where it can generate multiple tables, and reasoning models can then reason and figure out what metrics need to be called out, how contribution needs to be calculated, and then potentially also make this summary generation forward-looking, because right now this is only based on historical data. So we could add like a forecast agent and then make this into a forward-looking summary generation product as well. So yeah, with that, thank you for your time, and then yeah, any questions or feedback? Not. So in this case, I think I used Amazon Nova, but it's like I've not done benchmarking against Nova or Claude or even ChatGPT. I think GPT OSS is now open source, so with reasoning capability. So that's where I have the next steps to extend this work to cover the reasoning models that have been recently launched. Yeah, I think I did some experimentation with Claude as well, but it was not able to. So coverage is where I saw it was not able to capture the contribution. It was able to say, okay, for Q4 2025, units were this, and then price was this, but it was not able to compare across different time periods what is the percentage change, and then what is that actually do to the overall, let's say, revenue or profit. So that reasoning capability is still limited, and that's where I know like these models are becoming bigger and bigger. So eventually, like at some point, they will introduce some of these reasoning automatically, but yeah, that's still to be tested. Yeah.
So thank you for the very interesting talk. Is there a reason why you choose this sequential architecture workflow? Is it motivated by some kind of expert in the company that this is how usually the deal with work? Or have you also like think of incorporating like I know there's a scattered together architecture, also like hierarchical structure.
Mm-hmm. Yeah, I think with LangGraph you can define the design of your agentic framework. In this case, it was chosen to be sort of sequential because the task is very specific. So you would want to create the summary, and then you would want to execute all of these tools before you get to the summarization part, which is you need to get the data for creating the summary, then you need to quantify the contribution, and then only you would invoke the LLM. So if you essentially have a reasoning model on top, where reasoning model will decide what it wants to do, it can hallucinate and it can skip certain steps. So to make it more deterministic, sequential approach works better than putting an autonomy through a reasoning model to figure out what step needs to be executed, and then figure out whether that was actually completed correctly or not. So, yeah. So I think this is, I mean, so I don't think it is at a stage where it is like production ready, because there is still like human needed in the loop to look at the narratives and then validate whether they are factually correct or not, right? So imagine if you use such a system and then create the narratives and then send it to the leadership, and then some of the numbers that you have quoted as part of like the AI generated narrative are incorrect, right? So this is where that sequential and modular approach would work, but it still requires the validation at the final narrative generation step to make sure that all of the facts that are reported in the narrative are factually correct, right? And I'm still seeing with the agentic work frame, the coverage is still 60%. So there's still room for it to be like, businesses would want like 100% accuracy, right? In terms of like being factually correct. So until that happens, like you will always have like human in the loop to look at the first draft, and then at least that has the structure of the narrative, has some key figures, but you still need to validate with the source data yourself.
Does that mean that it will increase the waste for data validations and testing?
So it will still reduce some of the workflows because you are not doing any filtering and contribution calculation yourself. So it would still automate those steps. But then validation, yes, validation still needs to be done manually right now. Yes.
In terms of prompt dependency, is there any impact when it comes to standardization of prompts? Do you see any benefit or reduction in relevance or error in that sense? Relevancy of error?
Yeah, so that's a good question. I think I did not test with variants of prompt because depending on what you want in your final narrative, it can skip some of the facts, right? So prompt leads to the output. Even though you have all the data that you are feeding to the LLM, the prompt can actually make it less relevant, the final narrative essentially, right? So, but that's a good question, and yeah, I can definitely try out the variants of prompt and how does that impact coverage on the final narrative. All right, thank you.